Hey, students, had a couple more questions come in from chapter 3, in this case 13, 16, and 17. So let's take a look at those briefly. All right, annotate. Let me get my white space out here. So question 13 looks like this. All right. So it says, right, the first 10 counting numerals. All right, so we need the first 10. And let's see here. So counting numerals, if we were counting in base 10, that would look like 0, 1, 2, 3. Actually, counting would be a 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If we were counting in a different base, we would be grouping at different times. So for example, in base 3, now I'm regrouping every time I get to 3. All right. So again, picture this like poker chips. I'm trading them in. My place values for 3 are 1, 3, 9. And again, I could just keep multiplying by 3 every time I get to 27 if I needed to keep going. But now just count them out, right? Count. Count like you were counting normally. The number 1 in base 3 is still a 1. The number 2, here we go. Now I get to the number 3, which I want to write, but in base 3, the only symbols that are allowed are a 0, 1, and a 2. So I can't write a 3 because it doesn't exist in this system, but I can rewrite one group of 3 and 0 ones. Now again, all of these are going to be in base 3, so I'm just going to stop that right there. One, two, looks like 10. It's not 10 because in base 3 that would be 3. Next number would be 4, which would be a group of 3 and an extra 1. Then 5, a group of 3 and 2 ones. And notice again, I've got to the end. 3 is my next number, but I can't have a 3, so I will regroup. So here we go. It would be 2, 0, and that would represent the number 6. Then 6 plus 1, or 2 groups of 3 plus 1. 2, 2, which would again would be the number, what is it, 8? And then the number 9, I want to write 2, 3. I want to, but I can't. There's no 3 digit. So I have to regroup. Now, if I regroup here from 2, so there'd be 0 ones left. Then I'd come over here, and now there would be 3 groups of 3, but I can't write a 3. So I have to put a 0 there and regroup all the way over to the next place value, which would be the 9s. This right here says 9. I know it looks like 100, but if you look at the place value, it's 1, 0, 0. One group of 9, 0 3s, and 0 1s. So 1, 0, 0, and the next number would be 1, 0, 1, which would be 9 plus 1, and that, of course, goes back to 10. So that is how you write the first 10 counting numerals. I'll let you do the one for base 8. The one I just did was for base 3. We'll jump up here to number 16. Determine the greatest 3-digit number. Now, it does not tell me how to write that number, so I can write it using any way that I want. Now we have number 16 and 17 coming up, so I'll shade off a little white space here, and we'll even do, let's see, I think for the next one, I want to do, let's delete that one and bring this one up. I want to do the bottom one and maybe one of the other ones. I don't know if I'll do all of them. Okay, the greatest 3-digit number in each of the following bases. The greatest 3-digit number. Well, the greatest 3-digit number in a particular base would be the biggest one it can hold. If we were talking about base 10, the greatest 3-digit number in base 10 would be 999. And again, you could write the 10 here if you just want to kind of prompt yourself. And then it says base 3. So in base 3, think about the digits, right? What are my possible digits? My possible digits, I can't use a 3. The biggest one is a 2. So for a 3-digit number, the biggest 3-digit number in base 3 is 222. Okay. Now, if you wanted to write that, it just says 3-digit number. Okay. The greatest 3-digit number in each of the following bases. So the greatest 3-digit number is 222 in base 3. If you wanted to write that in base 10, for whatever reason, because it just said number, it didn't say a numeral in base 3. So you could say I could write it in any base. You're absolutely right. Yes, you are. Probably the quickest to write it in base 3. represents the same quantity. And then just go through and put your place values in. My place values would be 1, 3s, and 9s. So 9 times 2 is 18. 3 times 2 is 6. And 1 times 2 is 2. So 6 plus 2 is 8. 8 plus 18 would be 26. So this would be 26 base 10. Now, if you realize the next number up would be 27, right? So the next place value up would be 27, and we're one shy of that. So that would be another way to kind of think of, oh, the next place value, the next number that I would write would be 1000 because of all the regroupings. And so writing that would be 27. This number is one before that. And so instead of 27, we would write 26. All right, let's take a look. So yeah, there you go. You can do the next one. Find the numeral preceding and succeeding. So before and after. So picture this. If I gave you the number 100 in base 10, what's the number right before the numeral, in this case, right before, and the numeral right after? So the numeral right before this would be 99 base 10, and after that would be 101 base 10. So notice I'm adding 1 each time as I keep going. So it does make a nice arithmetic sequence. But if I added 1 to this place value, that would give me 10. I can't have 10, so I have to regroup. 9 plus 1 is 10 again, regroup, and that's why the next number would be 100. So if we do the same thing in base 7, so 100 base 7, I need the number before, the number after, so these are going to be in 7. And so the number right after, if you just add 1, yeah, that one's not too bad. You get 101. But in 100 base 7, right? So you want to be thinking, hey, what is that equivalent to? So very similar to what we did over here. We got 99, which is the biggest digit in our base. So if you have 100 base 7, yes, you would end up with 66 base 7. That would be the number right before this. If you added 1 to it, you'd get a 7. Can't write it. Regroup, get another 7, rewrite it, and you'd get 100. Let's try the last one right here. So 101 base 2. Okay, so the number right before this would just be 100. So I love that. That's a quick one, right? Because you just take 1 away. Well, I have a 1, so I can take it away. But now if I add 1 to this, which would be the number succeeding it, 1 plus 1 would be 2. I can't write a 2, so I have to put a 0 in that 1's place value. Then I bring a 1 over to the next, and I group 1 plus 0 is 1, and the 1 at the beginning had nothing to change. So that would be how I would count. If you really wanted to check, you are absolutely fine checking to see, hey, what would these actually be equal to or equivalent to? So this right here would be 1s, 2s, and 4s. So this right here would be the number 4. The next would be a 4 plus 0 plus 1. That's the number 5. And the number after that would be, again, with 1s, 2s, and 4s. That's a 4 plus a 2 plus no 1s. That would be the number 6. So this is what they are equivalent to, and you can kind of see how they're counting forward each time. So that's how you can go forwards and backwards. And that is going to wrap it up for this portion. Thankfully, I did not get an internet glitch or a Wi-Fi issue, so hopefully this recording came through real good. All right, I'll see you shortly. Off you go.